Hello, I am Dr. Sudha from Government Science College Autonomous, Bengaluru. In this session, let us discuss about the differential equations which are reducible to exact differential equations which were not discussed in the previous sessions. Differential equations reducible to exact differential equations. A differential equation which is not exact can be made exact on multiplying by a suitable factor called an integrating factor. This was known to us in the previous sessions. We have also discussed about the rules for finding integrating factors of the equation mdx plus ndy equal to 0, which were found by inspection, which were of the homogeneous equation form, and the equation of the type f1 of x comma y into ydx plus f2 of x comma y into xdy equal to 0, as well as an equation of the form mdx plus ndy equal to 0, which were not discussed in the above three types. Now in this session, we are going to discuss about the equation of the type a to the x to the power of a into y to the power of b into my into dx plus nx into dy plus x to the power of a dash into y to the power of b dash into m dash y dx plus n dash x dy equal to 0. Here a, b, a dash and b dash are integers, m, y, m dash and n dash are also integers. They can be negative, whereas a, b and a dash, b dash are positive integers. Now let us look into the rules for finding the integrating factor for such equations. For the equation of the type just now discussed, that is x to the power of a into y to the power of b into my dx plus nx dy plus x to the power of a dash into y to the power of b dash m dash y dx plus n dash x dy equal to 0. Integrating factor is x to the power of h into y to the power of k. And this h and k can be obtained by these two equations. Since we know the values of a, m, b, n, a dash, m dash, b dash and n dash from the given equation, we can find h and k using these two equations. Now let us solve some examples. Solve y square plus 2x square y into dx plus 2x cube minus xy into dy equal to 0. Now let us bring this equation to the equation of the form just discussed. That is, we are going to remove x square common between this 2x square y dx and 2x cube dy, as well as we can remove y common from y square dx and minus xy dy. So when we write that in the standard form, we get x square into 2y dx plus 2x dy plus y into y dx minus x dy equal to 0. Let us compare this expression with the standard form. So when we compare here we have x square, therefore the value of a is 2. But there is no y term, so we can take y to the power of 0, therefore b value is 0, m value is 2, n value is 2. And here we don't have x term, therefore x to the power of 0 can be taken, therefore a dash is 0. And we have y, so y power 1, therefore b dash is 1. And m dash is 1 because coefficient of y is 1. And n dash is minus 1 because coefficient of x is minus 1. So we get all these values here. Let us substitute these values in this expression because integrating factor is given by x to the power of h into y to the power of k. Let us substitute all the values, that is a, b, a dash, b dash, m, n, m dash, n dash, and we get 2 plus h plus 1 by 2 is equal to 0 plus k plus 1 by 2, and 0 plus h plus 1 by 1 is equal to 1 plus k plus 1 by minus 1. Here we can add 2 and 1. So h plus 3 by 2 is equal to k plus 1 by 2. And h plus 1 by 1 is equal to k plus 2 by minus 1. And on simplification, we get h plus 2 is equal to k minus h minus 1 is equal to k plus 2. And this on simplification gives us h minus k is equal to minus 2, h plus k is equal to minus 3. Solving these two simultaneous equations, we get h is equal to minus 5 by 2, k is equal to minus half. So the integrating factor, which is given by x to the power of h into y to the power of k, can be written as x to the power of minus 5 by 2 into y to the power of minus half. And now we have obtained the integrating factor, so we can multiply the given equation by this integrating factor, and we get x to the power of minus 5 by 2 into y to the power of minus half into y square plus 2x square y into dx plus x to the power of minus 5 by 2 into y to the power of minus half into 2x cube minus xy dy equal to 0. Now let us multiply these two factors within the brackets, and even here we multiply this within the brackets, and we obtain the equation of the form x to the power of minus 5 by 2 into y to the power of 3 by 2 plus 2x to the power of minus half into y to the power of half into dx plus 2 into x to the power of half into y to the power of minus half minus x to the power of minus 3 by 2 into y to the power of half into dy equal to 0. And this expression becomes exact as we have multiplied by the integrating factor. And we know that this is in the form of mdx plus ndy equal to 0, which is exact now. Therefore, the solution is given by integral mdx keeping y constant and plus integral wherein the terms of n not containing x into dy. Here in this n term, both the terms here contain x. Therefore, integral of terms of n not containing x becomes 0. Therefore, the solution is given by integral of mdx, that is this entire term integrated with respect to x keeping y constant, and that is equal to c, the constant of integration. Now let us integrate now the x terms. X to the power of minus 5 by 2 gives us x to the power of minus 3 by 2 divided by 3 by 2 into the y term, that is y to the power of 3 by 2 plus 2, the constant here. X to the power of minus half on integration gives x to the power of half divided by half into the y term, y to the power of half equal to c. On simplification, we get minus 2 by 3, x to the power of minus 3 by 2, y to the power of 3 by 2 plus 4 into x to the power of half into y to the power of half equal to c. And this is the solution to the given differential equation. Now let us solve one more example. Solve x square y minus 2x y square into dx minus x cube minus 3x square y into dy equal to 0. Now let us bring this to the standard form by removing x square common from x square y dx minus x cube dy. So we get x square into y dx minus x dy. And between the terms minus 2x y square dx and plus 3y x square y dy, we get xy into minus 2y dx plus 3x dy equal to 0. So this is in the standard form now. Let us compare with the standard form. Here we have x square, so a is equal to 2. Y to the power of b, here no y term, therefore y power 0, so b is equal to 0. And here y dx, so m is equal to 1. Here minus x dy, therefore n is equal to minus 1. Here we have xy, therefore a dash is 1 and b dash is 1. Minus 2y dx, therefore m dash is minus 2. Here 3x dy, therefore n dash is equal to 3. So on obtaining the values of a, b, a dash, b dash, m, n and m dash, n dash, we can obtain the integrating factor that is given by x to the power of h into y to the power of k, wherein this h and k are monitored by these two expressions. Now let us substitute for a, b, m, n, a dash, b dash, m dash and n dash to get 2 plus h plus 1 divided by 1 equal to 0 plus k plus 1 divided by minus 1. And 1 plus h plus 1 divided by minus 2 is equal to 1 plus k plus 1 divided by 3. And this on simplification gives us minus 3 minus h is equal to k plus 1. 3h plus 6 is equal to minus 2k minus 4. And further simplifying this, we get h plus k is equal to minus 4 and 3h plus 2k is equal to minus 10. Now solving these two simultaneous equations, we get h is equal to minus 2 and k is equal to minus 2. Therefore, the integrating factor x to the power of h into y to the power of k is given by x to the power of minus 2 into y to the power of minus 2, and that can be written as 1 over x square into y square. Let us multiply the given equation by 1 over x square y square, and we get 1 over x square y square into x square y minus 2xy square into dx minus 1 over x square y square into x cube minus 3x square y dy equal to 0. Now let us multiply the term within the brackets and we get the expression in the form 1 by y minus 2 into 1 by x dx minus x by y square minus 3 into 1 by y dy equal to 0, and this becomes exact on multiplying by the integrating factor. So this is in the form of mdx minus ndy, and we know that the solution of an exact equation is given by integral of mdx keeping y constant plus the terms of n not containing x into dy. So this term contains x, therefore we need to delete this or neglect this term and consider only minus of minus 3 into 1 by y, and that gives us 3 into 1 by y dy equal to 0. So the solution now is given by integral of 1 by y minus 2 into 1 by x dx keeping y constant plus 3 into 1 by y dy equal to c, where c is the constant of integration. Now let us integrate the first integral keeping in mind that y is constant. So 1 by y is retained as it is, 1 dx gives us x, minus 2 is retained as it is, 1 by x dx gives us log x. And in the second integral, 3 is kept as a constant here, and 1 by y dy gives us log y equal to c. And this is the solution to the given differential equation. Thank you.